Okay. Yeah, it works. Everything is just perfect. Hello and welcome. First of all, thank you very much for staying. That's the last session of the last day. And I take it as a compliment being here because the committee probably thought that I'm such an attraction that I will prevent people from going home too early. That's at least what I say to myself. So yeah, thank you for being here. And today we're going to talk about building a private continuous integration and delivery pipeline with Java and Docker. That's me. My name is Baruch. I'm developer advocate with JFrog at JBaruch all over the internet. And that pretty much summarizes what I do. I prepared a landing page for this talk today. It's under jfrog.com/show notes. You will see an entry for OSCON and then this talk. On this landing page, you will find the slides that are already there. By tomorrow, I will upload the video that we are recording here. Links of everything that I'm going to talk about, including, of course, the source code for the demo that we are going to see. A feedback form, and a small raffle just to thank you again for staying so late. So with that, that's the only slide you need to take a picture if you want to. Everything else is on the slides, which are there. Let's do something fun and see if you are still alive. So you vote for the option that sounds right, and then you keep your hand up all the way. It's not relevant anymore. So let's talk about Docker. Who heard about Docker? Did you hear about Docker? You sure? Okay, good. Can do the tutorial? Hands up, hands up. Most of you can do the tutorial, right? It's not that hard. Actually tried to do something, POC, played with it a little bit. I still see most of the hands up, and now production. You can take your hands down, that's okay. Okay, 1, 2, 3, production, 4, 4. Okay, that of course was a manipulation because I knew exactly that this is what is going to happen. And the question that we will try to answer today and try to solve the problem is kind of why people don't take Docker to production. There are a lot of reasons, of course. We're going to try to solve some of the problems in our talk today. So first of all of you heard about Docker, and I think the majority of you, if not all of you, tried it and know how it works. So I will do a very quick introduction of Docker in the next 5 minutes, and then I will go to a really neat and advanced stuff. So the idea of Docker is taking the idea of Java, for our example, one step forward. So Java was written on the idea of write once, run anywhere. When Docker actually takes this one step forward and talk about package once in your container, and you will be able to run it anywhere. At least that's the promise, and it actually works. And it brings couple of additional problems, but when you have your Docker container and it's probably built and you have all the external dependencies resolved, it will run pretty much anywhere, and that's the idea. Right, so Docker covers all the life cycle, starting from the build of your Docker images and then how you ship them to production, and then of course how you run them. And that's an example of a very simple that's the hello world in Docker, right? So I should say it's much less than hello world in Java, for that matter, right? It's much more concise. The file will probably be a little bigger than it would be the class file in Java. But the whole idea is that you take something that's called the base image, which is, think about it as the environment that you build on top, and then we run this command inside this image, right? So again, everybody know that? Everybody are on board? Good. Here is another example of a very simple hello world, and that's bringing the Java hello world into a Docker hello world. So now we use an image with Java already installed OpenJDK in this example, and then we copy the Java hello world, which is the hello world, hello jar, into it, and then we run this class, the app, in our example class from our hello jar in Docker, right? So again, I hope nothing new. We keep going into more complicated stuff. Now that's the workflow of Docker. What you need to remember is that Docker that you run comes in a client-server architecture. So you actually run a client. All the Docker commands run in the client. They talk to Docker host, which are usually in the same machine, but not necessarily have to be. And then this Docker host talks with Docker daemon that knows about the containers, which are, of course, the runtime environments, and the images, which are kind of recipes for those containers that we manage. Those images come from what is known in Docker lingo as registry. It can be Docker Hub, it can be other Docker registries that are there, like Amazon have one and Google have one, or of course it should be JFrog Artifactory and JFrog Bintray for the obvious reasons. So this is the workflow that we have, right? Those images are built on top of something that is called the union file system, and those are those base images that ramp up one on top of the other. Every layer that we add on top of a base image, or what is base for this particular example, becomes a new level in this file system, and it refers to the previous layers as read-only file systems as well. So here we go from the bottom up. All those are base images one to each other. We have some very root, which is the bootfs, and then we have a base image. In this example, it's Debian, and then we add some files to it. In our example, we add curl, and we add more to it. In this example, it will be CSM, Git, and then we add more to it. In this example, it will be OpenJDK, right? So every layer that we add is another Docker file that was run, that was built, and the image was created out of it. And this image serves as a base image for the next layer. And now when we run something like Docker images, we will find our OpenJDK, and Docker history will show us all those layers that were built into our Docker image. There is a nicer visual way to see that, and I will show it to you during the demo. Right, so Docker is a lot of stuff. It's the Docker toolbox, and it's the Docker itself. It can run on any operating system now. It can run on the cloud, in Amazon Web Services, in Azure, in Google Cloud Platform, etc., etc. There are a lot of options. So again, this is just to make sure we are all on the same page, and I really hope I didn't say a whole lot of new things to you. So now let's get to the question that we started, and that's why all of you who know Docker and tried Docker, actually most of you do not take Docker to production. And one of the reasons is that we don't trust Docker. We don't trust Docker not because it's a bad technology. We don't trust Docker not because we don't know how it works. And after this concise explanation, all of you, of course, know how it works, obviously. We don't trust Docker because it's an opaque black box that we are not sure what's going on inside. So playing with it on your machine and running Hello World and Java Hello World and POCing stuff is fun, but the next step of taking to production something that we are not sure that we intended to, it's very, very dangerous. And it comes from the lack of integrity, which usually comes with working with Docker. We are not sure that what we intended to put in our Docker containers is indeed what actually runs in our Docker containers. And I'm going to talk about that a little bit. But before that, just to kind of establish my credibility, why I actually want to talk about it, just a couple of words about JFrog and JFrog Artifactory in relationship with Docker. So just for you to, it's the last day of the conference, the last slot. That image might be confusing. It's a hug. It's frog hugging the whale, because we love Docker. Now, with that aside, this is Salman Hikes taking the stage at DockerCon 2015, more than 2 DockerCons ago, and speaking about Docker ecosystem and how no one uses Docker, and Docker only. And we can run this experiment here. Any of you work in an organization that only does Docker and nothing else? Obviously, no. That was the same answer in front of 5,000 people. And that makes perfect sense. The container analogy, Docker is a container, works well. No one actually cares about empty containers, right? You cannot make money from empty containers, and everyone has something besides Docker. And that means that you need a system that works not only with Docker, but with other technologies as well. We as JFrog do that for the last dozen of years. We manage binaries of all sorts, Java, Docker, .NET, NPM, and what's not. And that's why we believe we do Docker right. So we're going to talk about patterns. We're going to talk about how we establish this trust between the images that you have in your development and the images that your containers run from in production. And the pattern that we are looking for is how do we build continuous integration and delivery pattern. That's exactly a pipeline. That's exactly why you are all here. And this is not new, right? You know exactly how to do continuous integration for Java or for any other technology that you use. You do it for years. So what this talk is about, why Gradle with Docker is different. So first of all, this is how the normal pipeline looks like. We have this pyramid in which on every step of your pipeline, you have less and less builds surviving previous step, but the tests, in order to promote it, take longer and longer. We start with a lot of artifacts with unit tests. Most of them survive. Unit tests are very fast. And then we go through this pyramid. Somewhere there is probably a manual QA, which takes a lot of time, but you only have a few of builds to test. You got all this idea. Nothing new here. The same idea flipped on the side here. You have your binary files being whatever you build with. If it's Java, it might be wars, it might be jars, that you promote from one stage of the pipeline to another, from one environment to another, through those quality gates. That's a great image from a great book. It's called Agile ILM. Again, it's not a new book, but the concepts there are important and right, so you're more than welcome to look it up. Again, it's in the show notes right there. So those quality gates, we are going to talk about them as well. The problem, it doesn't work very well with Docker, is Docker build. Now, the interesting thing about Docker build that it's extremely simple and it's extremely powerful. And when you have something very simple and very powerful, we as developers are lazy, we will be more than happy to do that. To Docker build all the things. And instead of promoting binary files through those quality gates in the environments, actually promoting Docker build file. Promoting a text file is a very simple thing to do. All you need to do is tag it differently in your version control, and you have your pipeline. The problem is that fast and cheap builds are not the always way to go. And that's true story, by the way. The problem that we have here is unstable build file, Docker build files. That's an example of Docker file. So when I prepared this talk, I was like, okay, I need to craft some absurd unstable Docker file that no one will ever do, but I just want to drive the point home. So I will do something crazy that no one ever does, and then I went to the internet, and I didn't need to invent anything. Internet is full of those, and this is a true Docker file I have, again, in show notes, and a reference to it. It's in GitHub repository of some dude. It has tons of stars. People use it. People think oh, that's a good stuff. Let's use that. Right? That's a horrible stuff. Because almost every line, except of maybe creating a directory here and running some script, relies on the latest version of external dependency. So you can understand that the chances that the image that you created in development using this Docker file and the image that you created from the same Docker file in production, that they will be the same, the chances are like winning our TV in the raffle downstairs. Yeah. So, and now I think I had 5 people here that raised their hand that they run Docker in production. We have Mr. Ray Tsan here, who is Docker guru, Kubernetes guru from Google. So all of you should just shout now, but come on, this is ridiculous. That's just a bad Docker file. People can do better, right? Can we do better? Of course we can. Let's fix the from statement. How do we fix the from statement? I can have a version. That makes perfect sense. Let's add a version. Is it better now? No, why not?
Because that can change.
Oh, that can change. First of all, this is a very alarming statement, because this is a release version. In my universe, release versions never change. The binary file that I have under a release version should be the same when I touch it today or in 50 years. But in the reality, even release versions can change. Why? What is so important that justifies changing a release version? Security patches. Thank you very much. Ubuntu 14.04 was released in, obviously, April 14. Since April 14, something bad happened in Ubuntu. What was it? Not only Ubuntu, but also a Heartbleed. Thank you very much. I didn't pay this guy. He's just so good. So a Heartbleed happened, I think, in 14 after this release. Now, the good guys at Canonical that maintain Ubuntu have this trade-off of, you know what? We said the release is a release, so it have to be the same. And then we can trust guys out there to upgrade. And of course, that would be a very bad judgment, because the guys out there will not upgrade. So instead, they patched existing release version with security patches to incorporate the Heartbleed fix. So now when we download 14.04, it will include Heartbleed fix. Is it good? Yes. Is it reliable, the version? No. What can we do to make it reliable? Specify a build. Well, that's very close. In Docker terms, it's called a fingerprint. Now, fingerprint is a SHA-2 checksum of an image, which of course will not change, never change. Now, this is very solid, but anyone knows which version of Ubuntu is that? I think I just fell asleep on my keyboard, and that's what we got out of it. I'm not sure it's even a real checksum. No one knows. It's very stable, completely useless. Okay, so that aside, what about those guys? Can we fix those? Come on. Can we? Someone knows apt-get here? Of course we can. How do we fix them? We add versions. How do we know that we can add versions here? Because we know apt-get, right? But how about that? Who knows Maven? You guys are in Java thing. All of you should know Java, right? You know Java? Oh, you know Java. Okay, how stable is that? Do I know for sure that when I run this multiple times, I will get the same results? Yes. Well, mostly no. I can work very hard and make it stable. But for that, I need 10 years experience in Maven, which exists only 9 years. Okay, but I'll give you that. But how about that? How stable is that? Well, we have no idea, right? So my point here, I guess, is that there is no good way to guarantee that when you run Docker build multiple times, you will end up with the same image, right? I hope now you all agree with me. So this is why we don't trust Docker. Because this feeling of we're running something in production that was built in production and it can differ from what I built in development is scary, and it should be. So this is what we have. We run Docker build in different environments, and we end up with different containers. Now, instead, we can apply another pattern here that is called the immutable server pattern. Who heard about immutable server pattern? Okay, one hand. All right, that will be a very useful session for you guys. So Martin Fowler, and this link is again in the show notes, usually comes with very useful design patterns. One of them is immutable server pattern. Now what you see here is a traditional server that was a hardware, piece of hardware back in the days. And if you wanted to reconfigure it because some of the configurations weren't good enough, you just logged in SSH into it and reconfigured it. And if you have one server, it's fine. When you have 2 servers, it's fine. When you have 100, it's a pain. When you have thousands, it's impossible. But in our great new world, the servers are not hardware anymore. They are virtual, and that means that they are configured by software. If they are configured by software, we can get rid of this state manipulation by creating immutable servers. We write the configuration that will make the server behave differently, run new servers, and kill existing servers, right? This is what we do. And that's perfect. That's great. And this notion of immutability, we should apply it to Docker pipelines as well. And that sounds like a very simple thing to do, right? When we build a promotion pipeline, we do it with immutable and stable binaries. And this is what we should strive to. So we run the Docker build once, and then we promote through those quality gates. We promote our containers from development to production through the quality gates in all stages. And now that's not the first time I talk about the quality gates, and by now you should think something like, what's up with this guy? He's obsessed with gates. Well, I do have a good reason. As opposite. So yeah, what's up with the gates? It guarantees that only the right agents touch the right images. The QA shouldn't test their images. The non-staged tested images shouldn't get staged. And most importantly, any image should not get to production until it was tested, staged, and went through all the cycle. And the only way to guarantee it is make those quality gates as rigid and as unpenetratable as possible. And the easiest way to do that is just implementing different Docker registries in your pipeline. When you have Docker, different registries for development, for QA, for production, you can guarantee by using permissions that this will never happen. And you go like, okay, so I will have multiple registers on my host. What's so complicated? Well, not with Docker. Docker have this strange limitation, almost like this one, that we are going to talk about, and that's how Docker tag is structured. Now, this is a Docker tag command that, again, all of you, if you touch Docker, familiar with. And here's the problem. After registry host, so first of all, we specify a registry host, the source of our image inside our tag. This is quite unusual. Think about Java, right? When you download a jar file, when Maven resolves an artifact, you don't specify where to download it from per artifact. Think about NPM. When you do NPM install, you don't specify where the artifacts come from per artifact. In Docker, the host is embedded inside the name of the artifact. It has some advantages, of course, because it's very clear to see whether you are dealing with official image or not official image, but that's pretty much it for the benefits. The downsides is the separator between the registry host and the tag name. Now, they use /, and the problem is that // has been already taken for what, 25 years now. It's a separator in the URL. You cannot just take it and use it for anything else, because when it comes to specifying a host, and then a / and then a tag name, it means you cannot have multiple registries under the same host. Right? I mean, how can we support that if after the host we use separator and then the Docker image? Where will we put the name of our different registries? The dev, the staging, the prod, etc. Right? And it doesn't have to be like that. If only they used any other separator except of /, it'll be just fine. So what do? Well, naturally you do that when you realize, but there is a way around it. And the way around it is virtual ports or virtual hosts. And it allows us to work around this limitation. So this is the Docker tag command, Docker tag, and then the host, and then the name of our image. This is how the request looks like that goes into your registry. Again, host post, and then the name of the tag. And you need to transfer it, to transform it into that. So you have your host. You can have context name or not. Context name is not that important. But then you need to have here the name of your registry, right? And this is the development registry. You need to have it here before you have the tag name. So what we can do is using virtual hosts or virtual ports. Now that's example from Nginx, Apache, HTTPD, and HA proxy, and any other HTTP server have this capability of URL rewriting that can assign virtual hosts or virtual ports to do exactly that. So in our example, we create a virtual port, 5001. And all the requests that come to this port should go to whatever they intended to go, but inside a Docker dev registry. And we will have those blocks for every registry you want to have. We will have 5001 for dev, 5002 for staging, 5003 for QA, etc., etc. And then every port will redirect the request to different registry. This is how we work around it. And for example, in Artifactory, we have a generator of those things. When you create a Docker repository in Artifactory, you'll be able to assign different port or different host, and it will generate this part of configuration, and even sometimes, depend on how you install it, push this configuration into your Nginx and make it and activate it for you. And now there is another realization. How do you promote? How do you move your images from one registry to another? A normal way would be you download the file, you pull it, you retag this image, and then you push it back again, which is absolutely insane when you have your registries in the same host. Because all you need to do is move from one to another in the same host. It's actually not even a file move if you use checksum-based storage, again, like Artifactory. So how do we work around that? And for that, there is a solution as well, which is in our tool called a virtual repository. Virtual repository serves as a virtual Docker registry that can show you, that can expose one registry that backed up by multiple ones. So you can see here there is a Docker virtual that backed up by dev, testing, staging, production, and even a cache for Docker Hub. And then when we deploy when we push our image for the first time, it will be pushed, of course, to dev, because that's the start of our pipeline. And from here, we can promote this image inside Artifactory without pulling, retagging, and pushing it through the pipeline by using REST API. Now, any of those is a proper Docker registry by itself. So you can run whatever tools you want to run on it, or whatever integrations you want to integrate with, you can integrate with each and every one directly, right? And you can deploy to any environment that we have. So that's the theory. And now we have 10 minutes to actually talk about our example of this pipeline. So let's talk 2 minutes theory and look at the code for the rest of it. This is what we're going to build. This is our Docker image. Those are our layers. So we will use CentOS on the example, or as a base in this example. And then we will add our framework files, right, in which our application will run. In our example, it will be JDK and some application server. It can be whatever you like, Tomcat or whatever. And then on top of that, we will add a war file, which again can be anything you like, a jar file or anything else. So for our framework build, there are a couple of very important things. First of all, we use some base image. And we use the base image that we know that works for our environment. So for example, we tested that CentOS that we use is fine with the Java version that we need and all the services that we need. Everything is just fine. You add system dependencies from a trusted repository. So another example, it will be Artifactory, and we will use the RPM repositories of Artifactory for CentOS to download dependencies from. And it will be the JDK and Wildfly, the application server in our example. And this thing of a framework build is very important. And the most important about it is that you own it. Once you own the base image, you are protected from those updates into the base image that can be pushed without your knowledge. You will only update your base image when you feel it's safe. It can be as minimal as that. This base image doesn't do anything. It doesn't even add any system dependencies. It just takes a base image from an official repository and make it yours. Now you own it, and now it means that this one won't be updated without your permission or knowledge. And then on top of that, we have the application build. We use our base now, our framework, and then we run our Java build to generate our war file or jar file or whatever we build, and then we add a single file to our base. And this single file notion is important because the less changes you do to your application Docker image, the easier it is to manage, obviously. So this is our example of our application Docker file. So we have our base here. This is ours. And then we add one file from our repository to where the deployments go in this particular application server. We use here a release repository. And we use here a release repository. Should we? It depends. It depends on whether we have a separate pipeline for this file. If we can build and test and take through a pipeline of its own our application file, then of course it will end up in the release repository of its own. But if it only makes sense when it is in the Docker container, then of course it won't have a release repository because it won't have a pipeline, and we will take it from dev where it was built. So that's up to you. We use the latest release that it's out there. And it's good because this is the end of its pipeline. Every release that we have there is verified, so we can just go to the latest. More so, we use the latest release of our Docker image. And we spoke about not doing that, and now I do it. And that's because this is mine. I own it, I tested it, now I need my application to use the latest, because the latest is the right one. How do we test it? Well, what we're going to do, what I'm going to show you here, is something that is called sandwich testing. Anyone heard about sandwich testing? Good. It's a real thing. You can find it in Google, and whatever you can find in Google is real. We all know that, right, Ray? Google won't lie. And there is a thing that is called sandwich testing, especially when they prepare this, this for you, this summary for you. That means that they actually checked it, and that's a real thing, right? So sandwich testing is a real thing, and it's a flavor of integration testing when you do bottom-up and top-bottom at the same time. And what we're going to do here is exactly the same. We're going to run our framework pipeline against the latest version of our application, and our application against the latest version of our pipeline. And this is how we can guarantee that if one of them works with another, and the other works with the first one, everything is good. So we can prevent this situation by just making sure that we run that there are no mutual backwards compatible breaking changes. That shouldn't happen anyhow. And if we have good set of triggers that will trigger every one of the pipelines after each and every build, we're all safe. So now let's look at the same thing in reality. I think I need to close that in order for it to work. And here we go. Perfect. Okay, and that's very, very small. So I'm going to enlarge it a lot. Yes. Okay, that's better. Okay, so what we have here is two builds. As we mentioned, we have the Java build and the Docker build. And first is the Java build, which is a normal Maven build in this example that does nothing fancy but actually building some war file. It doesn't really matter. There is absolutely nothing interested here except of that we are going to deploy our war file into Artifactory once it is done. That's all it has now. Here is the, okay, who knows about Travis CI? Travis CI, okay, not bad. Couple of hands. Travis CI, who knows about Jenkins? Yeah, everybody knows about Jenkins. Right. Travis CI is a CI server like Jenkins, with the main difference that it's not that ugly and that it's in the cloud. Right? It's a service. We spoke about building the CI pipeline in the cloud, so that means that our CI server, as our source control, should be in the cloud as well. And Travis CI is a good option. So we're going to use that. There are a bunch of others. Shippable, Circle CI, Drone.io, CodeShip, and what's not. I personally like Travis CI. This is why this example in Travis CI, but it's the same as choosing between GitHub and Bitbucket. You just do one of them and it works fine. So now this is our Travis YAML. Travis YAML is the build configuration of Travis. And here's what we do here. We want the JDK to be installed, so we say it's going to be Java. And then this is our script. I run the deploy on Maven, and then there is a lot of testing going on, like automatic testing, the tests, everything. Very good stuff, reliable stuff right here. And then after all the tests were run, we're going to promote this build. This is the Java build that I spoke about that goes from development to production because we have a bunch of automatic tests right here that check everything. And then we promote it. Now, how we promote it? We promote it using a REST API. So we issue a request into our Artifactory server right here, and we say promote the build that is called CouchDB Java EE, the build number, whatever the current build number is, and then we promote it using Artifactory, we promote it into target repo, which is libs release local. Once we promoted it, we are going to trigger Docker build. That's a REST API call that goes to Travis and kicks another build. And that's because every time our Java build is ready and promoted, we need to build a new image. A new image will be triggering a Docker build. So that's the Java build. Now let's look at our Docker repository. And this is our Docker stuff. Now, here we have a Docker file that does two things, exactly as I showed you in the example. It takes our verified base, and our verified base comes from our Artifactory. This is the Docker JFrog IO. This is our registry. And then we add one file into it. And that's the file of the results of our Java build. We take it from the release repository. Where is my release repository? Right here, libs release local. We take it from our release repository, and we take the latest version that are there, and taking the latest version is completely safe here, because this is the test one, and we add this file to our Docker image. So that's our Docker file. And now let's look at how our Travis looks like, and that will be a little bit more complicated, but we will work through that. So we don't need anything. We just need a machine that we will run our own Docker on top of it. And before install, we're going to make sure that we have the latest version of Docker installed, and then we will restart it. So that's not interesting. This one is interesting. So first of all, we build this Docker file, Docker build, and we just tag it with the build file. Now we're going to push our image to Artifactory, and here there is nothing interesting as well. We just run the Docker push command, and we're all set with that. And Docker image is pushed to Artifactory, and now there are a couple of interesting tricks that is going on here that I want to show you. First is we are going to make an alias to the latest Docker image as latest. You know this latest Docker tag, which means nothing. You can tag anything as latest. Here, in an automatic matter, in our build, we make sure that our image that we just pushed is going to be called latest as well. We make a copy out of it, and we call it latest. Now, we're going to make sure that when we are looking at the latest, we actually will know which actual number it refers to. And we are going to do that by adding a property that is called Artifactory refers to version, and we're going to refer to the original version number. Right, so we establish here, we create a latest version, but we make sure that when we look at this latest, we will know exactly which version it refers to. And now, we are going to promote again the Java build that we looked earlier. Once we created the Docker image successfully and run some tests out of it, we are going to go back to our Java build, to our war file, and declare it as successfully contained in a certain container. Now, when we are going to look at the war file, we will know exactly to which container it was included in. And that, again, gives you this visibility that we spoke about. And lastly, we're going to establish the other part of this metadata. We are going to add a property on our build file that will say which Java build is contained inside this Docker image. So we establish bidirectional metadata, so we will know exactly which files are where. And here is the build that I just ran before, so I won't rely too much on the internet here. And this is my Java build. And Java build came first, of course. Is it? Yes, it is. That's my Java build. And let me make it even wider. Can I hide this thing somehow? No, I don't think so. OK, that's big enough. So here I run my Java build, and what it does, it actually downloads Maven, and then it runs the Maven build, look at how all the dependencies are downloaded from Artifactory, because you need to know control where your dependencies come from. That's all a Maven build, Maven build, Maven build. That's a Maven downloading the internet. And eventually, the build was successful, and here is the deployment part. So it gives us this URL that we can browse our build in. So again, let's make it bigger. And that's the build browser in Artifactory. That's our build 44. In our build 44, yeah, I am running late, right? Sorry about that. In our build 44, you can see all the information about it with the link back to Travis CI, and you can see here this WAR file that we created. In the release history, we will see this first step. So the first step was released, and that happened after automatic tests. So automatic test promoted this build to release, and this is what it looks here. And now we have our Docker build right here. Yeah, so you know what? I'll just show you the artifacts. So the Docker build created this image, the Couchbase E, and that's the last one, the latest. You can see here, you remember Docker history command? Here it is in like a nice manner, so you can see everything that happens. Hey, look at that. That's our file that we added. You remember? The thing is, you have no idea which file is it, but as you remember, we have it in metadata. And we know that this latest actually refers to a version 74. Here is a version of 74, and this 74 have a build, Java build number 44. So we know exactly here that number 44 was contained inside this Docker image, and that's what release history shows. So this is all for me. And just to make sure you won't forget, we have this, whoa, what's this guy? Here. We have this show notes that I prepared for you with the slides, with the video by tomorrow, with all the links, feedback form, raffle. And by the way, this great background of Napa, California is just to remind you that a JFrog user conference called the Swamp Up is coming up in 2 weeks in Napa, California. And it's a great conference that you definitely should attend. Ray will speak there, and I will speak there, and it will be a lot of fun. Since that's the last talk of the conference we have all the time in the world for questions. If you have any, thank you very much.